Somewhere in the Indonesian archipelago, on islands so remote they feel like the edge of the world, an ancient predator waits. It has been waiting for 65 million years. It doesn't chase. It doesn't hurry. It doesn't need to. Because once it bites, the clock is already running out for its prey. This is not mythology. This is not legend. This is the Komodo dragon, and what science has uncovered about the secret inside its jaws will fundamentally change everything you thought you knew about how this animal kills. Meet Varanus komodoensis, the Komodo dragon. It is the largest living lizard on Earth, with males growing to an extraordinary 10 feet in length and tipping the scales at up to 330 pounds. Pound for pound, muscle for muscle. This is one of the most formidable apex predators on the planet. It lives here, and only here. The Komodo dragon is found exclusively on the Indonesian islands of Komodo, Rinca, Flores, Gili Dasami, and Gili Motang, with the largest population concentrated within Komodo National Park in eastern Indonesia. A UNESCO World Heritage Site, a place where time seems to have stood still. Walk through these sun-scorched hills, and you're not just visiting Indonesia, you're stepping into the Mesozoic. You're walking alongside a living ghost from an age when reptiles ruled the earth. Because of their remarkable size and group hunting behavior, both exceptional among reptiles, Komodo dragons are apex predators dominating every ecosystem in which they live. They are, in every measurable sense, the dragon of our world. But here's where the story gets extraordinary. For decades, nearly a century, scientists thought they understood how the Komodo dragon killed. They were wrong. The truth, when it finally emerged from a laboratory in Melbourne, Australia, sent shockwaves through the scientific community. The Komodo dragon doesn't just bite, it poisons. The story begins not with science, but with a story. In 1969, an American biologist named Walter Aufenberg arrived on Komodo Island with a notebook and a theory. He spent a year watching the dragons, and in 1981 published a book on their behavior that won him an award, and also enshrined a myth that would take almost 3 decades to fully dismantle. Aufenberg had noticed that when large animals like water buffalo were injured by the dragons, they would soon develop fatal infections. Based on this observation, and no actual evidence, he suggested that the dragons used bacteria as a form of venom. When they bite, they flood wounds with deadly microbes from their mouths, which then debilitate and kill the victim. It was a compelling story. It made intuitive sense. And for 30 years, it appeared in every nature documentary, every school textbook, every wildlife guide to Indonesia. But it wasn't entirely true. Researchers had long accepted the theory that the Komodo dragon killed via blood poisoning caused by the multiple strains of bacteria in its saliva, a so-called dirty mouth designed by evolution to deliver slow death. The only problem? When scientists finally looked closely, and I mean really looked, the bacteria story began to fall apart. Ellie Goldstein, an expert on microbes from the UCLA School of Medicine and an advisor on unusual bite wounds worldwide, helped study the bacterial composition of Komodo mouths. His conclusion was damning. The bacteria as venom model seemed to be based on faulty and dated studies with no really good data to support it. And as for those notoriously filthy mouths, contrary to popular belief, Komodo dragons actually have good mouth hygiene. After feeding, they spend 10 to 15 minutes lip-licking and rubbing their heads in leaves to clean their mouths. They do not have chunks of rotting flesh on their teeth cultivating bacteria. The legend was crumbling. Something else had to explain the dragon's lethal reputation, and in 2009, the answer finally arrived, from inside the dragon's own jaw. In 2009, Dr. Brian Fry and a team of 28 scientists published a landmark study in the Proceedings of the National Academy of Sciences that changed everything. Using MRI scans and a preserved Komodo dragon skull, they found something no one expected. 2 long venom glands running the full length of the lower jaw, each consisting of 6 separate compartments, with ducts leading from each one to openings between the teeth. These are the most structurally complex venom glands of any reptile on Earth. But what really stunned scientists was what was inside those glands. The team found that the Komodo dragon's venom rapidly decreases blood pressure, expedites blood loss, and sends a victim into shock, rendering it too weak to fight. Some compounds in the venom that reduce blood pressure are as potent as those found in the world's most venomous snake, Western Australia's inland taipan. Read that again. Compounds as potent as the inland taipan, widely considered the most toxic land snake on the planet. Dr. Fry calculated that a typical adult dragon would need only 4 milligrams of venom proteins to send a 40-kilogram deer into toxic shock from collapsing blood pressure. A full venom gland packs at least 8 times that amount. This wasn't a random biological quirk. This was evolution building a precision weapon. The known functions of these venom proteins include inhibition of blood clotting, lowering of blood pressure, muscle paralysis, and the induction of hypothermia, leading to shock and loss of consciousness in envenomated prey. Slow, systematic, unstoppable. Now that we know what's inside the jaws, let's talk about how the Komodo dragon actually uses it. Because the venom is only one part of a 3-part killing system. Based on a thorough analysis of the dragon's skull, Dr. Fry described what he calls the grip, rip, and drip tactic. The dragon bites down with serrated teeth, then pulls back with powerful neck muscles. The result is a massive, gaping wound. And here's a stunning plot twist that no one saw coming. Despite being the size of a small car, the Komodo dragon's bite force is surprisingly weak. Computer modeling showed it exerts just 39 newtons of jaw force, compared to the 252 newtons of a saltwater crocodile. A bite of crocodilian strength would fracture the Komodo's own skull, so the Komodo dragon is not built to crush, it is built to slash. Its skull is adapted to resist strong pulling forces, not compression. Like great white sharks and saber-toothed cats, it compensates for a relatively weak bite with sharp teeth, powerful neck muscles, and venom. The teeth themselves are a marvel. Serrated and laterally compressed, designed like a shark's teeth, to slice through flesh and open wounds so severe that blood loss becomes catastrophic almost immediately. And then the venom drips in. Silently. Relentlessly. Rather than killing prey instantly, the Komodo bites and releases, then waits. As the venom spreads through the victim's bloodstream, it becomes progressively weaker. Blood pressure drops, blood refuses to clot. The prey collapses from hemorrhagic shock, sometimes hours or even days later. And the dragon? It just follows, tongue flickering, reading the scent trail on the air, patient, merciless, inevitable. The Komodo dragon is not a passive scavenger. It is an active, strategic predator. The diet of adult Komodo dragons consists mainly of Javan rusa deer and feral pigs, though they are also known to take water buffalo, and on rare occasions have attacked humans. Its primary hunting weapon, before the venom even enters the picture, is ambush. The dragon uses its surroundings with remarkable patience. It will hold absolutely still, camouflaged by its rough, mottled skin against the dry brush, and wait for prey to wander within striking range. Then it moves with terrifying speed, covering ground in a powerful sprint before delivering that characteristic slash and release bite. But how does it track prey across miles of rugged island terrain? The answer is on its tongue. The Komodo dragon's forked tongue is one of nature's most sophisticated chemical sensors. Every flick, and it flicks constantly, sometimes 30 or 40 times per minute while tracking, delivers airborne scent molecules to Jacobson's organ in the roof of its mouth. This system is so sensitive it can detect a blood trail from more than 5 miles away. Think about that. 5 miles. On a remote island. Through dense scrubland. In heat that would send most predators to the shade. The dragon follows anyway. Observations of Komodo dragons hunting deer, boar, and buffalo reveal that they kill prey in less than half an hour during successful hunts, often in just a few minutes. They do not wait for prey to die and track it from a distance the way vipers do. The mythology of the slow, bacteria-based death was always overstated. In reality, when conditions are right and the dragon commits to a kill, it ends fast. Here is where the Komodo dragon stops being just a predator and starts being something that could save human lives. Researchers have isolated a powerful antibacterial peptide called VK25 from the blood plasma of Komodo dragons. Based on analysis of this peptide, scientists have synthesized a shorter compound dubbed DRGN-1 and tested it against multi-drug-resistant pathogens. Preliminary results show that DRGN-1 is effective at killing drug-resistant bacterial strains and even some fungi. It also significantly promotes wound healing in both uninfected and infected wounds. In a world where antibiotic resistance is becoming one of medicine's most pressing crises, the Komodo dragon, this ancient reptile from a handful of remote Indonesian islands, may hold part of the answer. Millions of years of evolution built this animal to survive wounds, infections, and environments that would kill almost anything else. Its blood has been shaped by those same pressures into a biological toolkit that human science is only beginning to understand. It is, as scientists are beginning to realize, not just a predator. It's a pharmacy. Every great predator has a beginning. For the Komodo dragon, it begins in a nest dug into the hillside, where a female lays between 15 and 30 leathery eggs, and then, in a remarkable display of maternal commitment for a reptile, she guards the nest for up to 9 months. But from the moment the hatchlings emerge, they are on their own. And here's why they immediately sprint for the trees. Adult Komodo dragons are cannibalistic. They will eat juveniles without hesitation. The trees offer a refuge where larger adults can't follow. Young Komodos spend their first few years arboreal, hunting insects, small lizards, and birds among the branches. They roll themselves in the fecal matter of larger dragons to make themselves smell unappetizing, nature's version of camouflage. It takes roughly 8 to 9 years for a Komodo dragon to reach sexual maturity. They can live up to 30 years. They spend most of that life at the top of their food chain, growing, hunting, and shaping the ecology of their island world. And the Komodo dragon has one more biological trick up its sleeve that even Darwin himself might have found hard to believe. Parthenogenesis. Female Komodo dragons can reproduce without a male. They can produce fertilized eggs from unfertilized ones, a phenomenon documented in captive females at the Chester Zoo in England and the London Zoo. The hatchlings are male. This ability may have evolved to allow isolated females to establish new island populations. In a species where survival is never guaranteed, the Komodo dragon finds a way. For all its power, for all the millions of years it has dominated these islands, the Komodo dragon faces a threat it cannot bite, ambush, or outrun: us. The Komodo dragon is currently listed as endangered by the International Union for Conservation of Nature. Fewer than 1,400 adult Komodo dragons are estimated to survive in the wild. Their entire global range is smaller than the state of Rhode Island. Rising sea levels, a direct consequence of climate change, threaten to shrink or submerge the very islands the Komodo dragon calls home. The Indonesian government briefly considered closing Komodo Island to tourists entirely in 2019 in a bid to allow the ecosystem to recover. The tourist economy and the preservation of the species are caught in a difficult, ongoing negotiation. What is clear is this: once the Komodo dragon is gone, there will be no recovering it, no recreating it. This is a species shaped by over 40 million years of evolution, and it is hanging by a thread. The Komodo dragon is more than an apex predator. It is a keystone species, and its presence regulates the entire ecology of its island world. Remove it, and the system unravels. For the people of the Indonesian islands of Komodo and Rinca, the dragon is not a curiosity. It is a neighbor, a spirit, a reality of daily life. Local communities have coexisted with Komodo dragons for generations, and traditional ecological knowledge, passed down through oral history, has informed how scientists now understand the dragon's behavior and territory. In recent years, ecotourism has transformed the relationship. Komodo National Park draws tens of thousands of visitors annually, and the dragons themselves have become the engine of a local economy. Rangers, guides, boat operators, and village businesses all depend, to varying degrees, on the continued presence of the world's largest lizard. When the dragon thrives, people thrive. It is a lesson in conservation that goes beyond sentiment. Preserving biodiversity is not just an ethical imperative. It is an economic one, a medical one, a human one. Between 1974 and 2023, there have been only 36 recorded human bites by Komodo dragons, resulting in just 5 fatalities. For an apex predator of this size sharing space with human communities for decades, that is a remarkably low figure, a testament to both the dragon's natural wariness of humans and the respect local communities have developed for it over generations. There are creatures on this earth that don't need our stories to be remarkable. They have already written their own, in bone and blood and venom and time. The Komodo dragon existed before our cities, before our language, before our science. It hunted in a world we cannot imagine, and it survived every mass extinction, every climate shift, every predator that thought it could challenge a living dragon. For 50 years, we thought we understood how it killed. We were wrong, and we were humbled, as science often humbles us, into something better than certainty. Wonder. The venom hidden in its jaw is not just a killing tool. It is a window into the evolutionary history of all venomous reptiles, into the biological secrets that may one day cure our most resistant diseases, into the extraordinary possibilities that still wait, undiscovered, in the wild places of this world. But only if those wild places survive. Only if we choose, with the same intention that evolution chose the Komodo, to preserve what cannot be replaced. The dragon is still out there, waiting, watching, ancient and alive. And as long as it endures, so does the wild pulse of this planet.